Today's video will explain the levels of malleability. Hello, I'm James Helfrich. Malleability is a software quality metric describing how easy it is to make changes to code, to adapt to new features, or to change the functionality. This video will define the levels of malleability, as well as show an example of how to improve the malleability in a given function. So there's two components to maintainability. One is understandability, and the second is malleability. And malleability is a measure of how easy it is for a programmer to make changes to a system. There are 5 levels of malleability. The best is configurable. Big changes can be made without altering any code. The next is data-driven. Alterations can be made without changing the logic of the program, but we do have to change the source code. Adjustable. Small changes can be made without altering much code. Refactorable, refactoring and redesign are required for most tasks. And finally, prohibitive is easier to start over than to change the code. Now, in order to demonstrate these 5 levels, we're going to start with a problem, and this function is going to compute the tax burden given an input. And this is the tax table from the 2006 income tax. And notice how the different tax brackets are not evenly distributed. We'll start with prohibitive malleability. Code is considered prohibitive when even small and trivial changes require substantial reengineering. In almost all cases, it is far easier and less risky to just start over. So let's take a look at this function to compute tax. Now, oh boy, this looks really bad. Let's see if we can figure out the different tax tables here. So the minimal amount is values of 0, and then the fixed amount to add to the tax is values of 1, and then the tax rate for a given bracket is values of 2, and the income is values of 3. Okay, so let's take a look at the lowest tax bracket, the 10% tax bracket. So it's between 0 and $15,000, and then that's 10% of the amount over 0. So let's see here. Look at that return statement at the bottom, values of 0, which is going to be 0, plus values of 2, which is my rate, 10%, times then my income, which is values of 3, minus then values of 1, which is my fixed amount. And so that's going to be 10% of my income. So that kind of works. Okay. The second tax bracket, $15,000 to $61,000. So if I'm greater than $15,100, so I'm going to the if statement, and then I'm going to take values of 0 and I add 15,000 because that's my minimal amount. And then my $1,500 is going to be the fixed amount. And then my values of 2 is going to be 0.1 plus 0.05, which is 0.15, which is 15%. In other words, what I seem to be doing is tabulating and adding onto my values as I go. The next tax bracket. So I'm going to take my old minimal amount and I'm going to add $42,200. Oh, but that's added onto 15,000, which gives us $61,300. So I'm not seeing the actual value from the tax bracket because it's kind of added onto, it's computed. So this works, but keep in mind that if I have to change my tax brackets, I'm going to have to modify a whole bunch of code. It's going to be very complicated. I have to redo all this stuff. It's going to be very risky. One more example here, the very bottom one, the $336,000 to infinity. So that's going to be, let's say my 35%, which is going to be values of 2. So I'm going to start at 0.1. I'm going to add 0.05, add 0.1, add 0.03, add 0.05, add 0.02. All that is 35%. So it does work. Okay, so why would someone do this? Why would someone go through all this work? Well, if they're optimizing too much for efficiency as opposed to maintainability, then we're going to have convoluted code like this. And frankly, if I'm going to have to adjust my tax bracket, which I'm going to have to do every year, it's far easier for me just to throw this all away and start over again. This is an example of prohibitive malleability. One level better than prohibitive is refactorable. Code exhibits refactorable malleability when anticipatable changes require refactoring. In other words, the code requires significant reworking and reengineering before the programmer can even start to make the required changes. Okay, so here's our compute tax function again. I seem to have the numbers for my tax brackets, but things are a bit amiss. Let's take a look at this. First of all, our 10% tax bracket, so my income divided by 10. Okay, that makes sense. And then I'm going to have my 15% tax bracket. So I'm less than 161 and greater than 115. So all the numbers are there. And then income minus 15,000 plus times 10% plus 1,500. So all the numbers are there. I could see that easily. Okay, my 25%, well, I'm going to be greater than 161,000, but less than the one under it. And once again, all the numbers are there. And then finally, my 35% tax bracket. Okay, one thing you'll notice about this is for each bracket, it's computed differently. My 10%, I'm just going to divide by 10. And then in my 15%, I'm going to have the fixed amount on the end. On my 25% tax bracket, I'm going to have the fixed amount in the beginning. In other words, what happened here? What probably happened is different developers implemented each different tax bracket differently. Now, this all works. Now, because they're all done differently, then it's going to require more work than necessary in order to move the tax brackets to different values. So what I'm probably going to have to do is refactor all of these equations so they're all consistent before I even begin the work. And that's refactorable malleability. One level better of refactorable is adjustable, and this is the first level of malleability that is actually desirable. Coders consider to exhibit adjustable malleability when most alterations can be made without altering the structure or the overall design of the code. So now I'm going back to my tax brackets here, and we're going to see that my 10% is right there, and then my 15%, and then my 20%, 25%, sorry, and then my 35%. Now, each one of these done consistently. They're all done in a way that's super easy to map the problem domain into the actual code. It does not require a skilled programmer to make these updates. In fact, any novice programmer can come in and adjust this code and expect it to work the first try. My testing burden is going to be minimal with this. So this is a good or desirable level of malleability. But can we do better? One level better than adjustable is data-driven. Code is considered data-driven when alterations can be made without changing the logic of the program, without changing the logic. So here's an example of data-driven. And notice how all the values, the minimal, the maximum, the fixed amount, and the rate are all pulled into a separate table, whereas the logic is in a different place. Now I can adjust the contents of the levels as well as the number of levels without actually altering any code. And so my 10% tax bracket is just these numbers right here. My 15% is these numbers right here. My 25% is these numbers here. And my 35% numbers here. Once again, just like with adjustable, I can have a very novice programmer come in here and make these changes without risk of really breaking anything. And it's super easy just to look at the code and verify that we got everything right. So data-driven is definitely superior to adjustable. But can we do better? Code can be considered configurable when large and substantial alterations can be made without changing any code whatsoever. So I'm going to have a file here called tax bracket, and it's going to have the low, high, rate, and initial amount, all the same numbers I had in my data-driven, but now they're in a separate file. And then my code is going to read the file and then apply the tax bracket. Now, the cool thing about this is I don't even need a programmer to make this change. Any secretary can make the change, or I can even grab this off an external source like the internet. In other words, the executable itself can stay consistent, even though the behavior is different by changing the configuration file. Now, the first example we had of this was ID Software in the 90s represented the game of Doom. And all the levels in this first-person shooter were not actually baked into the executable, but in a separate configuration file, which means any novice can come in and make their own level to come up with gameplay that was not even anticipated by the designers of the program, which meant that you can drastically change the functionality without having access to the source code. And that's what configurable malleability offers you. We can learn more about malleability in the Characterizing Malleability section of the Maintainability chapter of the software design textbook.